Lesson 8.1.10, Transforming Angles, Angle Measures in Parallel Lines. In this lesson, we'll do a lot of things. Describe the effects of a rigid transformation on a pair of parallel lines. And if I have a pair of vertical angles and know the angle measure of one of them, I can use vertical angles to determine missing angle measurements. And finally, identify congruent angles on two parallel lines cut by a transversal, and use that to determine missing angle measurements. All right, there is no way we are writing all of those learning targets. We're going to try and condense it just a little bit. We'll narrow it down to two. We're on page 43, and we are going to be identifying congruent angles. Formed by parallel lines cut by a transversal line. We'll talk about what a transversal line is in just a moment. Cut by a transversal line. And one more. We'll use vertical angles to find missing angle measures. We'll talk about what vertical angles are. You probably saw them in the past, but we'll remind you. Use vertical angles to find missing angle measures. Okay. So we've got a lot of vocabulary to tackle today that's important. Vertical angles and what a transversal is. Let's start with vertical angles. Start with our definition of what a vertical angle is. Vertical angles are opposite angles formed by intersecting lines that have the same vertex. Opposite angles formed by intersecting lines share the same vertex. Let's go ahead and draw some here. I'm just going to grab a ruler. Try to grab a ruler. Here we go. And I'm just going to draw two intersecting lines. That's what is going to help us to see vertical angles. Okay. This is opposite angles. Let's see what we mean by that. Let me grab a pen here. Let's take a look at this angle that's formed by these two sides and this angle. Those are opposite angles formed by these two intersecting lines, and they share the same vertex. Say this one's 45 degrees. What we know about vertical angles is that vertical angles always have the same measure. If that's 45 degrees, then this is 45 degrees. So vertical angle measures are always equal. And while we're here, it might be worth talking about how we can use vertical angles to find other angles in these intersecting lines. I'm going to line my ruler up right there and just show you that one of these lines, well, these two angles together are going to form supplementary angles, angles that should add up to 180 degrees, because from here all the way to there is 180 degrees. So if this whole thing is 180 degrees, and I know that 45 of it is taken up here, then I can conclude that this other angle made by these two, these two rays is 135 degrees. If I take 180 and subtract 45, I'm left with 135. And we might as well go all the way around the circle, because now I can say that these two angles are vertical angles. They're opposite angles formed by intersecting lines. So their measures are equal. And if we were to add all of these up, going all the way around the circle, it would add up to 360. So really, I have two pairs of vertical angles here, these 45s and these 135s. I want to be clear on what vertical angles are not. Say I have a bunch of intersecting lines, and I know that the measure of this angle is like 127 degrees. I can't introduce another line over here and look at an angle that doesn't have anything to do with that 127. This is not a vertical angle to that. Okay, they're not on opposite sides of these two intersecting lines. They have to have the same vertex. Say this is 40 degrees. So these two are not vertical angles. We'll be looking at vertical angles a lot in some of our figures to come when we talk about parallel lines and transversals. But that's our other vocabulary word, transversals. And a transversal is a line that cuts across two or more other lines. Line that cuts across two or more other lines. And we're going to be looking at how a transversal can cut across two parallel lines. In fact, I'm going to go ahead and draw two parallel lines. That's really what our lesson had a lot of today. Just going to have to believe me that these are parallel. Continuing on forever and never touching. And a transversal is a line that cuts across those. So this is our transversal line. In fact, let me do a little bit of highlighting here. Transversal line is that line that cuts across two or more other lines. Let's talk about some important facts, and we'll come back to those parallel lines. If I have parallel lines intersected by a transversal, then the transversal is going to form pairs of congruent angles. Parallel lines intersected by a transversal form pairs of congruent angles. And since we're talking about parallel lines here, I'm going to go ahead and show you a symbol that's often used to indicate that lines are parallel. So if I want to say that this line is parallel to this line, you might see notation where there's little arrows on the two lines. Not the arrows on the ends that show that it continues infinitely, but these arrows say these two lines are parallel. And while we're here, let's show an example of something that's not a transversal. So if I have that line, I wouldn't call this pink line a transversal line because it only intersects one line. It has to intersect two or more. Oops. All right, here's where the magic starts. With this summary task, it says here's a pair of parallel lines and a transversal. This is what I mean by those little arrows indicating that we have two parallel lines here. Those are our parallel lines. They're cut by this transversal line. That's a line that cuts through two or more lines. And we're given one piece of information. We're given this 145-degree angle. Let's take a look at how we can use just that one to figure out the measure of all the other angles that are formed by these three lines. And what we're really going to be using are what we know about vertical angles, angles that we can translate, angles that we can rotate, and supplementary angles. Remember, those are angles that add up to 180 degrees. All right, watch this. So we have this 145-degree angle. And maybe you can already see the angle that's vertical to that. It's on the opposite side of these two intersecting lines. So I know that this angle is 145. So I know that this angle is also 145 degrees. Really, if I wanted to, I could pivot this around and show you that that's really just a rotation. There's other ways to find the measure of that angle, but it'll rotate to be the same thing. Well, if I know that this is 145 degrees and I have these two parallel lines, I can translate this angle right down my transversal, and I end up with this angle over here, which is congruent and also 145 degrees. Right there. Well, now I have another set of vertical angles on opposite sides of these two intersecting lines. If this is 145 degrees, then this angle is 145 degrees. So just with this one angle, I'm able to fill in three more. But we're not done yet. We can use what we know about supplementary angles. Let's just focus on this 145-degree angle. Get a different color here. Oops. For our purple. There it is. If I'm looking at this pink line, if this is 145 degrees, then this angle must be the rest of what it would take to make 180 degrees. So if I take 180 and subtract off 145, that leaves me with the measure of this angle, 35 degrees. Well, if that's 35 degrees, then this angle, which is a vertical angle, is also 35 degrees. And just like I was able to translate that 145 degrees right down this pink transversal, I can do the same thing with this 35 degrees. I can take that angle, translate it right down to here. And if that's 35 degrees, maybe you can see this new set of vertical angles. This is 35 degrees as well. So if I have two parallel lines cut by a transversal, and I just know one of those angles, then I can fill in the measure of every other one that's part of those two intersections. So today's lesson gives us some vocabulary to work with. Our important words today were what a transversal is, what vertical angles are, and in your homework, you'll be able to use those facts to find all kinds of missing measurements. Good luck.